Okay. Are you able to hear me? Hello? Three zero five. Okay, right. Okay, right. Right. So we'll take up this problem in the previous class. Just I think I asked you note down this problem. Then we'll discuss the solution. I think most of you note it down. So we'll see today. We'll see the solution for this also. So first I'll read the problem. Then we'll see its solution also. A pair of parallel helical gears consists of 24 teeth pinion rotating at 5000 rpm and supplying 2.5 kilowatts power to a gear. The speed reduction is 4:1. Normal pressure angle and helix angle are 20 degrees and 23 degrees respectively. Both gears are made of hardened steel SUT 750 Newton per mm square. The service factor and factor of safety are 1.5 and 2 respectively. The grades are finished to meet accuracy grade 4. So this is the problem data. In the problem data, he has given the number of teeth on the pinion and he has given the speed reduction, means you can calculate the number of teeth on gear also. So speed reduction is 4:1 means 24 into 4 is going to be the number of teeth on gear, and pinion speed is given, and power transmitted is 2.5 kilowatts, and normal pressure angle is 20 degrees and helix angle is 23 degrees. And also mentioned that both the gears are made of same material, which is hardened steel, having a ultimate strength of 750 Newton per mm square. Service factor is 1.5 and factor of safety is 2. And also the finished surface have accuracy of grade 4. Now the first question or first part of the question is, in the initial stages of the design, assume the velocity factor accounts for the dynamic load and that the phase width is 10 times the normal module. So assuming the pitch line velocity 10 meters per second, estimate the normal module. So he has not given the value of module in this problem. So asked us calculate normal module Mn. So for this, he specified some conditions. You need to consider the pitch line velocity as 10 meters per second. And also the phase width will be 10 times the module. So phase width is 10 times the normal module. So these are the conditions he specified for this. So since he has given the number of teeth, so I can calculate what are the virtual number of teeth because with the help of this helix angle. Once I know the helix angle, then I can calculate what is the beam strength and I can calculate what is the effective load also. So then factor of safety is 2 is given. So then for safety, based on this velocity factor approach, your beam strength should be equal to the P effective. So then from that I can calculate the normal module. So that is the first part of the question. Second one is, select the first preference value of the normal module and calculate the main dimensions of the gear. So once you calculate the module, he asked us select the value from the first preference list for the normal module. So whatever normal module you choose, the value for that normal module should be taken from the first preference. So in the table, 28.3 or something like that he has given. So you have to, from the table, you have to choose the module value only from the first choice or first preference value. Then third part of the question is determine the dynamic load using Buckingham's equation and find out the effective load for the above dimensions. What is the correct factor of safety for bending? So then in the first case he asked us calculate the dynamic load based on velocity factor. So then asked us calculate what is the normal module. Then in the third part, instead of using velocity factor approach, he asked us use Buckingham's equation to find the effective load. That means you have a different formula for dynamic load if you want to use Buckingham's equation. So using that, you can calculate the dynamic load. Once you calculate the dynamic load, your effective load is nothing but CS into PT, that is tangential component of force, plus dynamic load. So we'll get that. So once you get the P effective, again he asked us calculate what is the factor of safety for bending. So then for bending, what you already calculated the beam strength. So therefore factor of safety is nothing but beam strength SB divided by this P effective. So you get the factor of safety. So he asked us what is the correct factor of safety. That's it. So no, if you want, you can go for modification also if the factor of safety is not for as per our requirement. That's what I shown in the solution also. Anyway, we'll discuss that. Then finally, he asked us specify the surface hardness for the gears, assuming a factor of safety of 2 for wear consideration. So you have to consider wear consideration, and for a wear consideration, you need to consider the factor of safety as 2. So then for that, what should be the required hardness of surface of the gears? So that's what he has given in the problem. Okay. Now we'll see the solution step by step. So first, the given data, power transmitted is 2.5 kilowatts. Is it 2.5 kilowatts? Yes. It is 2.5 kilowatts. Then speed of the pinion is 5000 RPM. Is it 5000? Yes. Number of teeth on pinion is 24. Speed reduction or speed ratio is 4. Helix angle is 23 degrees. Normal pressure angle is 20 degrees. SUD is 750 Newton per mm square. CS is 1.5. Factor of safety is 2. And grade of machining 4. So we'll see. We don't require this one also. Okay. So because we are following. Okay. You need to calculate the dynamic load based on the Buckingham's equation, where you need to calculate the error. So for that error, so we'll take the equivalent thing from the data book instead of grade 4, something like that. It is not available in the data book. So we'll convert this grade 4 into equivalent of parameter which is given in the data book. Based on that, we can calculate this E value. So first we need to estimate the normal module based on the dynamic load using velocity factor. So for that, we know the torque transmitted. The formula for the torque transmitted is 60 into 10 power 6 into power in kilowatts divided by 2 pi n, not ng. Here it is a mistake again. So it is np. So this is speed of the pinion, because the speed, we know speed of the pinion only, so we'll use that one only. So if you substitute that, you will get the torque as something like this value 4774.648 Newton mm. So only thing is you have to substitute the power, which is 2.5 kilowatts. You have to substitute in kilowatts, and you have to substitute what is the speed of the pinion. He has given it as 5000. So from that you will get MT is equal to 4774.648 Newton mm. So why I am calculating MT is, if I know the MT value, I can calculate the PT value. Then if I know the PT, I can calculate the effective force. So to calculate that PT, you require this dP dash. So your PT is nothing but MT is equal to PT into dP dash by 2. So from that you will get PT value, but for that you require this dP. So dP is nothing but dP dash here. It's not dP. It is a virtual. It is a pitch circle diameter of virtual spur gauge. which is given by ZPMN cos psi. So ZP, see, because both are made of same material, the design is based on the pinion only. So that's why we are using the parameters of pinion here. So ZP is the number of teeth on the pinion, which is 24. Mn, unknown value, so we'll keep it as Mn itself. Cos psi is 23 degrees. So ZP is 24. So if I substitute that, I'll get dm as 26.072 Mn into Mn. So Mn is the normal pitch, which is unknown. So units are Mn. So now I can calculate PT value. Like I said, PT is nothing but 2mt by dp dash. So 2mt value is 4774.648 divided by dp. dp is 26.072 Mn. So if I substitute that, I'll get the tangential force as 366.25 divided by Mn newtons. So once I got this, then I'll use the velocity factor approach to convert this PT into P effective. So that is nothing but P effective is CS into CV into PT. So for that, CS is already given in the problem as 1.5. No need to calculate it. I'll calculate CV. CV, for I said, for always helical gear, this is the formula. Whatever may be the pitch line velocity, you need to use this formula for calculating the velocity factor CV. So 5.6 plus root V by 5.6. So he mentioned that you need to take this V, pitch line velocity, as a 10 meters per second. So we are taking that one as a 10 meter per second here. So if I substitute that 10 meter per second, if you simplify this, we get CS as 1.5646. So now I have CS, CV and PT. Now I can calculate the effective load. So or else straight away here I written the equation, that is beam strength equation. Beam strength is equal to your P effective. So P effective into FF, factor of safety. This is the design equation. So CS, CV, PD into FS is going to be your effective load. So that is CS is 1.5, CV calculated as 1.5646 and PD calculated as 366.25 by Mn, and factor of safety is given as 2. So if I simplify this, I'll get 1719.205 divided by Mn Newton per mm square. And also we have a beam strength equation in terms of this normal module and Lewis form factor and allowable stress is something like this, SB. So equal to Mn B into sigma B into Y. So in that, Mn is unknown to us, so we need to calculate Mn. B is given as 10 times Mn. So in the problem itself, he mentioned that you need to take the face width as 10 times the normal module. So B is equal to 10 Mn. Sigma B is nothing but SUT by factor of 3. SUT by 3 will take it. And Y is the Lewis form factor. And this Lewis form factor can be calculated through interpolation of the teeth for two values. So we'll consider all those values now. Sigma B is nothing but SUT by 3. SUT 750 is given. 3 by divided by 3 is 250 Newton per mm square. And B is given as 10 times the normal module, 10 Mn. And ZP. So now to calculate this Lewis form factor, you should know what are the virtual number of teeth on the pinion. That is ZP dash. The formula for that is ZP divided by cos cube psi. So ZP is 24, number of teeth on pinion 24, helix angle is 23 degrees. So if we substitute that, we get number of teeth as 30.77. Like I already told, whenever you are calculating the virtual diameters and virtual number of teeth, you cannot round it off. So whatever value you got it, you have to take those values only. Here also, if you round off this value, then it is going to be wrong. So no, you cannot round off this value. Whatever value you got here, exactly you have to take that value. For this value, for this number of teeth only, you have to calculate the Lewis form factor. So don't think that there won't be 0.77 teeth. So then either you can take 31 or 30, like that. Don't round it off here, because These are not the actual number of teeth. The actual number of teeth is only 24. Actual number of teeth on the gear. That is the practical number. So 24 only. So there is no fraction. But only in case of virtual teeth, you will have a fraction value. Even though you have a fraction values in the virtual number of teeth, you have to use that fraction value only. So now, based on this 30.77 number of teeth, you need to find the value of y. So for that, in the data book, he has given for 30 and for 32, he has given the values. So we need to calculate the value for 30.77. So that value can be obtained by interpolation of the values corresponding to the 30 teeth and as well as 32 teeth. So for 32 teeth, so if you refer the 28.33 of our design data book or the material what I shared with you in the WhatsApp group, if you refer the table 28.33 in that, for 32 number of teeth, of course here the pressure angle is 20 degrees, you need to remember that one also. For a 20 degree pressure angle and then 32 number of teeth, your y value is 0.364 and 30 number of teeth it is 0.358. So now I'll use, this is the interpolation formula to calculate the least form factor for 30.77 number of teeth. So if I do that, I'll get y as 0.3603. So now in this equation, I know everything except Mn. So I have to calculate the Mn. So therefore, by equating the effective load or this one, that is SB from the power transmitted to the beam strength, I will get the module, normal module. So first, if I substitute all these values into this equation, SB is equal to Mn into B into sigma B into Y. Mn is unknown, I'll keep it as Mn itself. B is given as 10 times the normal module, 10 Mn. Then sigma B is 250 and Y is calculated as 0.3603. So if I simplify this, I'll get it as 900.77 Mn square. Okay, it is in Newton per meter. It is in Newtons or Newton per meter square. I think I'll check it. So it is factor, all these are factors. So it's not here, it is a mistake, it is only Newtons only, not Newton per mm square. So here it is a mistake, it is a beam strength expressed in Newtons only. So now here you have a beam strength in terms of Mn, here this one also in mm. So then for design safety, these two should be equal. So therefore I need to equate 1719.205 by Mn to 900.77 Mn square. So if I equate these two, then from this equation I'll get Mn value as 1.24. So that is the calculation of normal module based on the velocity factor. So that is the first part of our solution for the first part of the question. Then second part what he has given is you need to choose the normal module from the first reference value. So now if you open the data book, in that you open the table 28 I'll say in my book it is 25. Maybe those who are having new edition, for them it is chapter number 28. So if you refer table number 25.2 for me, maybe for you it is 28.2. So in that preferred choice, so what is the value preferred choice in that, what is the value we can choose it here? So do you have data book with you? Nobody is responding. So we are sitting idly. Whether you have data book with you or not, even nobody knows. Whether you are following it or not, also nobody knows. Then why you are attending the class without any response? So in the data book, if you choose the first preference value, you have to take it as 1.5 mm. You can take it as 1.5 mm. So that is the answer for the first bit. So second bit is, so based on that you need to calculate what are the dimensions of the gears. I have a doubt whether my voice is audible to you or not, whether you are present in the class or not. ఏ కిష్ట చరణ్ ఉన్నావా క్లాస్లో?
సార్ ఎస్ సార్.
నేను చెప్పేది నేను మాట్లాడేది వినపడుతుందా?
ఎస్ సార్, ఎస్ సార్, ఎస్ సార్.
ప్రజెంటేషన్ కూడా ఉందా? కనిపిస్తుంది బాగానే స్క్రీన్?
సార్ కనిపిస్తుంది సార్, కనిపిస్తుంది.
మరి ఎవరు రెస్పాండ్ అవడే? ఉందా డేటా బుక్ నీ దగ్గర?
ఎస్ సార్.
చూసావా టేబుల్ నెంబర్, టేబుల్ అది
చూస్తున్నాను.
Okay, so once you fix the normal module as 1.5 mm, then face width is nothing but 10 times the normal module, which comes out as 15 mm. Then pitch circle diameter of your virtual gear, virtual spur gear, dp dash here, which is ZPMN by cos psi, which comes out as 39.11 mm. So then similarly virtual diameter of the gear is comes out as 24 into 4 into 1.5 by cos 23 degrees, which is 156.44 mm. So that is the second part of the question. Third part is, instead of using velocity factor approach, you need to use the Buckingham equation to calculate the effective load and also find the factor of safety. If required, you asked us to calculate the factor of safety also. So for that, first we'll calculate the beam strength. So we got the module value 1.5. Earlier we calculated it, but that value is in terms of unknown Mn only. If you see this calculation here, problem number 1. Here it is in terms of Mn, even here also it is in terms of Mn only. So therefore, first we will substitute this Mn value either here or here, anyone is okay. So first we calculate what is the beam strength. So then this is going to be the 2026.6875 newtons is the beam strength. So then you need to, in order to calculate the factor of safety, what you need to do is you need to calculate the effective load also. So for that we require tangential force. So earlier tangential force also in terms of Mn only. So now we can calculate, because we know the diameters. So you can calculate the pitch circle diameters of known. If you substitute that, you will get PD as 244.165. Then here he has given that the gears are finished to meet the accuracy of grade 4. So in the data book that grade 4 or grade 6 or grade 8 or like that, it is not there in the data book. Even though in the problem he has given it as a grade 4. So here I written a statement. We'll assume that. So the gears are treated as precision gears and the value of E for a normal pitch of 1.5 mm is equal to 0.0125 mm. So this value I have taken from table 28.36. So that means that material what I shared to you through the WhatsApp, in that this table is there. Table 28.36. So to pick the value of E, what is the criteria? What type of gears you have chosen? So here grade 4 we choose it as a precision gears. So we'll treat the grade 4 as a precision gears, and the pitch value is 1.5 mm. Based on these two things, you can pick this value from the table 28.36. So he has given up to 4 mm module of up to 4 mm. You can choose this 0.10125 for a precision gauge. So from the data book you can pick that value. Again, above that you have one more table which is 28.35. From that you can pick the deformation factor value, deformation factor C value. So since it is made of steel and steel, both gear and pinion made of same material, so both are steel only. So then in that case, for 20-degree full depth, steel and steel. So that means pinion and gear both are made of same material. 11,860 into E is Newton for mm is going to be the value for C. So once you have C and E values, then you can calculate the velocity V also. That is the formula for velocity is pi dp np by 60 into 10 cube. So if you substitute that, you get 10.239 as meter per second as the velocity. Then you can calculate the dynamic load. So this is the formula for calculating the dynamic load for a helical gear. So you have cos square psi here and cos psi here also cos square psi. So these are the additional terms you need to include for a spur gear. Of course, this formula is there in the data book, or what is the material shared by me, in that also it is there. If you refer that, you can clearly see that also. Okay, so once I know this PD value, so that in this now I know everything. I know C value, I know B value, I know psi, I know PT. Everything is known. Now I can calculate dynamic load. Just I substitute the corresponding data into this. 21, 10.239 is the velocity. You got it here. You just calculated, and then C into E. So C is nothing but C into 11,860 E. So therefore, if I substitute for E as 0.0125 here, I get it as C as 148.25. Then B is 15 mm module, 10 times the normal module. So normal module is 1.5 mm. So then 10 times the is 15. So I'll get 15 cos square 23 plus PT is computed as 244.16. Then cos psi is nothing but cos 23. So like this, I'll substitute the data, and if I calculate it, the dynamic load comes out as 1613.09 newtons. So you have PT, you have CS, and you have a dynamic load. From this, you can calculate your effective load. Your effective load is P effective is nothing but CS into PT plus PD, which is 1.5 into 244.16 plus 1613.09. So which comes out as 2101.41 newtons. So this is the effective load. If this effective load is less than your beam strength, then it is safe. Otherwise, it is going to fail under bending. Or else, we'll calculate the factor of safety. If the factor of safety is more than 1, your design is safe. Otherwise, it is going to fail. So therefore, we need to calculate he asked that also. What is the correct factor of safety? So now, the formula for factor of safety is SB divided by P effective. SB we got it as here it is in reverse written, I think. So what is the value of SB beam strength? This one 22,026.6875. That is the value of SB. You need to take. You need to modify that here, and then here this value is 2101. You need to modify this one also, numerator and denominator. So then, if you calculate that, you will get the factor of safety. Okay, anyway, I'll check that. I'll modify that also. We'll do that. And we'll check what is the factor of safety also. So, for beam strength, this is the value you need to consider. So, this is the beam strength value. So, here you have to take beam strength. And here you have to take P effective. Denominator should be your P effective. Now we calculate what is the factor of safety here. Obviously, it is less than that only 26.6875 divided by 2101.41, 0.964. 0.964 you will get it. So that means your design is not satisfactory because the factor of safety is less than 1. So, but in the problem, as per the problem, what he has given is you have to calculate what is the correct factor of safety. So that means what is the actual factor of safety for these dimensions. So you can end up in the solution at this point. So that is enough. So for the problem, what he has asked is this is the enough. This part up to this part it is enough. So only thing is he asked us calculate what is the factor of actual factor of safety. The actual factor of safety is 0.964. Then if you want, you can add the statement also because the design is unsatisfactory, both not worth both from standpoint of strength. Not satisfactory from the standpoint of strength. So if you calculate, if you take beam strength as the criteria, so from the beam strength point of view, it is not set. It is unsatisfactory because your factor of safety is less than 1. So now if I want to modify this, then what I have to do? So then what we'll do is to modify this. So we need to simply change the module value, normal module value. So we are taking pitch value as 1.5 and with the 1.5 we are getting a factor of safety is 0.964. Again I am telling you. So this is the next step is we are doing additional one. But as for the problem up to this point it is sufficient. If you do up to this point it is okay, it is enough. But as a academic point of view or if you want to modify the design, how we can do that. So what we have to do here is only thing is you need to increase the module value. So therefore in the modification I'll choose the normal module as 2 mm instead of 1.5 mm. I'll take it as 2 mm. Then I'll do the same process what we did previously. So we need to calculate B and DP, DC, and you need to calculate the effective load for these values, and also you need to calculate what is the beam strength also for these values. Okay. So DP is this one. Mn is 2. If we choose Mn as 2 mm, B is equal to 20 mm. DP comes out as 52.146, DC comes out as 208.586 mm. Then your beam strength will also change because here we have changed the Mn value and also accordingly your B will also change. So your beam strength now comes out as 3603 newtons. Then you can calculate tangential force. The tangential force will also change if you change the module. So accordingly it is not changing because your MT and DP here you need to make some correction here. Actually it is not 39.11, it should be 52.146. Okay, anyway, so you do that calculation also. I'll also do from my side. We'll do that modification here. 4774.648 into 2 divided by 52.146. You need to do that, which is 183. It's not 244, is 183.126. So here you have to consider it as 52.146. That is the diameter. So the circle diameter of the pinion is 52.146. So in that case, you will get your PT as 183.126 newtons. If you do the calculation, you will get that value. Okay, once I got the PT value, then I can calculate same thing. So error is going to be same, C value is going to be same, then V is going to be now with the value of D as 52.146. If you compute V, we get it as 13.65 meters per second. Then you need to compute with that V value, PT value, and psi value, you have to compute the dynamic load. So here also you need to make the modification here. That means you need to recompute it again. So here I taken it as 244.16, but our PT now it is 183.126. So you have to substitute that value 183.126. So with this value you have to calculate. So if you calculate that value, what you need to check what is the value you are going to get for PD. So you do the calculation and tell me what is the value of that one. Cos 23 square into 15 into 148.25 plus 183.126. So it comes out as 2067, 2067.37. Okay, in the numerator also you will get the same thing. Square root 45.46. Okay, now if you want to calculate that, 2067.37 into 13.65 is the velocity into 21 divided by 21 plus 45.46 into cos 23. So now you tell me what is the value you are getting for this. $2067.37 into cos 23 divided by 21 into 13.65 plus 45.46. Plus 45.46 1 by x into 27.37 into 21 into 13.65 into cos 23. 1642. So you are getting it as 1642.53. 1642.53 as the dynamic load. So you need to modify that one here also. 1642.53. So and even this one also you need to change. Dynamic load is 183.126 plus 183.126 into 2. So it comes out as 2008. 2008.78. So then here also you need to substitute the same thing. 2008.78. Then 1 by x into 3603 is the beam strength. Then factor of safety comes out as 1.793. Okay, so this is the modified calculation. You need to modify the calculation like this and you can do that. So anyway, I'll show it is. So power problem is there, power failure. Just now it came back. I'll reconnect. So be on the line. Okay, now now as am I audible to you?
Yes, sir.
Okay, so right. So I'll show the calculation now. So if you substitute this data, you'll get the dynamic load as 1642.53 newtons. Then effective load is nothing but CS into PT plus PD. So CS is 1.5, PT is 183.126, and PD is 1642.53. Just calculated. If you substitute that, you will get effective load as 2008.78 newtons. Then the factor of safety is going to be again SB by P effective. Now the SB is 3603 divided by 2008.78. Then the factor of safety comes out as 1.793. So now you can say the design is satisfactory because your factor of safety is more than, even it is more than 1.5. So then it's okay. So like this you can do it, but only thing is if he asks in the question modify the design to meet the requirement, then you have to do it. Otherwise, if you ask calculate the correct factor of safety, means you do up to that point, then it is okay. You can stop at that point, it is okay for that problem, even for this problem also. Okay. Suppose if you ask to modify, then you have to do this one. Additional, you need to, only thing is you need to change the model and you need to repeat the same process. That is the only thing. Such that you should get a factor of safety more than 1. Then the last part of the question is, what is the surface hardness required for the gauge?
Sir,
So,
sir.
yes,
Presentation కనపడట్లేదు సార్.
okay, it is not visible.
Yes, sir.
Okay, so maybe I not presented more. Okay, yes. Yes, so these are the calculations I want to show it to you. So I think this is already done. So we need to calculate the dynamic load. So we got the dynamic load as 1642.53 newtons. Then your free effective is this one. Then the correct factor of safety comes out as 1.793 for this module. Then you can say the design is satisfactory. So then the last part of the question. So what is the surface hardness required for the gauge? So then for that your SW is nothing but, so always your surface hardness is estimated based on the fitting failure. So for that you need to know what is the wear strength. Wear strength is nothing but P effective into Fs. So P effective is 2199.57 into 2, which comes out as 4,399.19 newtons. So once you know that, then this is your ratio factor, formula for the ratio factor, Zg, 2 into Zg by Zg plus Zp. Number of teeth on gear is 96 and on pinion it is 24 is given. So Q comes out as 1.6. Then this is the formula for our wear strength. So from this you can calculate the what is the K value. So B is known to us because we are taking the normal module as 2 mm. B is going to be 20. Q is just calculated as 1.6 and the DP is already calculated, which is 52.146. K is unknown for us. We'll treat the K as K itself. Cos square psi is nothing but cos square 23 degrees. It should be equal to, so or if it is, this is equal, if you simplify this, you will get it as 1969.33 K. So then this should be equal to this P effective into Fs. So which is equal to 4399.14 newtons. So then from this we get K is equal to 2.234. So once you have K, then you have a relation between K and sigma BHN. So sigma E, in turn sigma E is related to BHN. So the relations are, first relation between K and sigma E is this one. So your K is equal to sigma E square sin alpha n into 1 by E1 plus 1 by E2 divided by 1.4. So in that sigma E is unknown for us. We'll keep sigma E itself. Alpha n is 20 degrees. 1 by E1 and E2 is taken as 2.07 into E5. Then K is 2.234. So from this, if you simplify this, in this equation only sigma E is unknown. You can calculate sigma E. So the sigma E comes out as 972.85 Newton per mm square. So once you got sigma E value, then you have a relation between sigma E and BHN. So the relation is sigma E is equal to 2.8 times BHN minus 70 Newton per mm square. So this is the relation. So in this, if I substitute sigma E as 972.85, so then I'll get the BHN value. So which is 372.45, which may be rounded up to 380. So this is the solution. Like this, we can solve this particular problem. Okay, right. So I want to discuss this much in this class. Maybe in the next class, we have a little bit discussion about herringbone gears that we'll discuss in the next class. So far in this class or in this problem, if you have any doubt, then you can ask. Or else it is clear to you, then respond to the attendance sheet and you can leave the class. Okay, I think nobody will speak. So we are becoming just dummies.